Bruce, can you see the chat screen? There's a question for you.
Okay, let me go to the, I think I might have to stop.
So do you provide any warning based on the data you get through the device? For example, if someone's blood pressure or oxygen saturation is low or high, higher than the normal level? So
Interesting. We can do that on a clinical basis, and actually, this is something that we're really trying to explore. So here's the problem. The problem is the FDA won't approve those kinds of devices, and certainly not with wrist wearable devices. At least they haven't so far. And so, in order to have a generally FDA regulated device in the market, you have to get through FDA approvals, and that's a tough nut to crack. So we like the idea, though. So there's a way to get around FDA regulations, and yes, our device can do that. We haven't really done that yet because we're just getting our device out into the market right now. But that's one of the number one things on our list, is to be able to alert people. The thing is, you can't alert people. What you have to do is you have to alert a medical professional who then can contact the individual, who can decide whether or not the alert is relevant, and then they can contact the individual. And there's a way that you have to do that. So I think it's a great concept, but that concept is still working its way through the regulatory procedures.
Right. Yeah, due to time limit, I have one last question from Stephen. The question is about the health goals. Can you collect blood sugar data or plan to support some functions for diabetes patients in the future? Because I feel that it will be, hang on, where it's jumping. Yeah, because I feel that will be very valuable, even can save lives. Yes.
Yeah, absolutely. I mean, so we can collect blood sugar data from a device that's emitting blood sugar readings. That data can flow directly into our application, and then we can compare that application to your activity and food and whatever else you track. If you're asking whether or not this device will collect blood sugar, no, it won't, because it doesn't have the correct sensors to detect blood sugar. But I can tell you that there are companies that have so-called non-invasive blood glucose detection, and there's a company here actually in Alberta, and we've been talking with them about their device, and they have a really interesting technique that will non-invasively read glucose directly through your skin. I think it uses microwaves, if I'm not mistaken. So, but it's that's coming. I think that we're going to have those devices emerge soon.
Right. So thank you again, Bruce. Now I pass to Zhiyi to introduce the next speaker.
Right. Thanks, Bruce, for this brilliant talk. So we need to jump to the next section. So let me do a brief introduction of Professor Zehua Wang. So Dr. Zehua Wang, he obtained his Ph.D. degree in the electronic and computer engineering from University of Columbia in Canada. So another, I think we are all we all graduate from Canadian universities. So this is a kind of a good thing to have all these people gather together. So he, after graduation, he actually went to the industry, and he served as the chief scientist in RightMesh in Canada. And this company also was commended by Prime Minister Trudeau. And he is now a research professor in the Department of Electronic and Computing Engineering, also in UBC. His research area including his area including privacy preserving machine learning, state channel technology, and decentralized authentication and authorization. Also, he is the first professor in Canada, I think, provide a blockchain course to the university students. So I think now I have to hand it over to Dr. Zehua Wang, and yeah.
Okay, thank you. Just double check, can you guys hear me and see my screen?
Yes, we can.
Okay, perfect. Thanks for the introduction from Tim. Thanks and thank you for your invitation and for the talk to invite me to give the talk. I'm very honored here, and I also want to acknowledge the very good presentation from Bruce, and then thank you all the audience attending the meeting here. So today we'll talk about something between the machine learning and the blockchain. So just as Bruce said, and also some audience and asked the question. Also, Irene also asked the question about the privacy for the machine learning stuff. Yeah, so we can see that data privacy becomes a very important issue nowadays, because a lot of those learning companies, they require more and more data. But the data actually originated from the user, like the customers. Okay, for example, when you buy something in Amazon, your data is actually sucked by Amazon, and when you do the web browsing, web searching, Google is sucking your data. But when we think about the machine learning for the future, then we will realize that the data privacy is even more critical problem, because right now, then people talk about the 5G, some new technologies. People talk about the wearable devices. And also in the Bruce presentation, we also see that some wearable devices can just sensor the heart pulse, okay, and the pressure, the blood pressure, something like that. So right now, then when we face into the future, when we have the 5G technology, when we have the wearable devices, and also considering those automatic driving cars, okay, we have the sensors everywhere, but those data could be very critical, okay, and then the data sucked by those big or giant data hosters, okay, the big the data servers, your privacy may be leaked out. So I think that should be something something should be done and in the blockchain technology, and to help us to do the machine learning, and while we can somehow protect the data privacy. So that's the concept for today. Okay, blockchain for data privacy in deep learning. It's just a table of content. Today we will just we have already done a couple of days of the presentation, so I will quickly go through the concept for blockchain, and then the smart contract, the theorem, and deep learning. And later on, then we will highlight the background and motivation for this kind of research. So what blockchain? We know that the data can be saved in the blocks. Okay, we have some consensus algorithms, including the very famous Prof work, Prof stake, and the delegated Prof stake. Okay, so those are very famous consensus algorithms. Right now, there are also some new consensus algorithm proposed for the proof of elapsed time. Okay, so POET. But basically, they are just the similar thing. So we do not want to have the data saved in the centralized server. We want to have the data saved in the blockchain upon the consensus, and we want to bring some difficulties of rewriting the history. Okay, you know that for our work, that if you want to change the history of the blockchain, you somehow need to beat the computational power for the rest of the world. And then you can somehow have the chance and to have the longer chain, longer than all of the other miners in the peer-to-peer network. And eventually then all of the miners can just adopt your chain and mining after your chain, and then you can just change the history. But theoretically, it's not possible, because it's very it's almost impossible for one computer to beat all of those computer powers in the real world. And so that people can trust the data, right? People can trust the data in the blockchain. People can trust the transaction data. But we know that in the transaction of the blockchain, So those data are just binaries. Everything, okay, when you have these things in the internet, when you have these things on the network, everything is binary. So the binary data can be the transaction data, but the binary data can also be the bytecode. So that we want to mention the Ethereum smart contract. People say that the Bitcoin is the first, blockchain version 1.0, because we do not have the Turing complete language for Bitcoin. It's just a opcode, because we do not have the for loop. We cannot jump back. So what's the opcode working in the Bitcoin? It is just like a stack machine. So for example, when you want to calculate the 1 plus 2, as a human, we know 1 plus 2 is equal to 3. But for the stack machine, we push 1, we push 2, and when we see a binary operator plus, we pop both of them and have the result 3, and we push that 3 in the bottom of the stack, the result is 3. So the opcode in Bitcoin is just like the stack machine. And then so stack machine cannot support the just like jump, okay, or go to. So we say that the Bitcoin, it is somehow it's not a Turing complete. It's not a Turing machine, and the opcode running in Bitcoin, it is not a Turing complete language. But something changed in the Ethereum. Okay, by Vitalik, so we have the Ethereum, we have the blockchain 2.0. Blockchain 2.0 means that we can run some code in the arbitrator's manner. Because I said the binary data can be the transaction data, but the binary data can also be the bytecode. So people right now using the Ethereum, people know that we can code in Solidity, we can compile the Solidity into the bytecode, and we can run the bytecode in the Ethereum virtual machine. Just like that, as long as you have heard Java, even though you have not yet program in Solidity code, but as long as you have code in Java, you should know Java code will be compiled into the bytecode, and the bytecode can be runnable in everywhere that has a Java virtual machine. The similar concept. Right. So the most important thing that the blockchain can bring us is that we can trust the data on the blockchain, means that we can trust the program in the blockchain. If we can trust the program in the blockchain, then we can somehow agree that if I give the same input to the same bytecode, okay, and then no matter what's the location of the computer, as long as you have the you are a part of the blockchain, as long as you have this piece of bytecode in the block, and that block is in your computer, then if I give you the same I just give the input, and then you should give me the correct output by using the remote procedure call. Okay, so that makes us can do a lot of things. It's just like we can outsource our computation power. And we know that the machine learning definitely costs a lot of computational power. And together with the blockchain storage functionality, and then we can also save some intermediate result in the blockchain. For example, when we do the neural network training, when we have the backward propagation to upload those weights in the neural network, we can save those weights in the blockchain. And so people all over the world, so the people can read the data from the blockchain and then continue using the existing neural network to have their local data trained, okay, to upgrade the knowledge saved in the smart contract or saved in the blockchain. So it's just can turn out that the people do not need to contribute their raw data. People can contribute their knowledge, okay, because people can agree. Every country in the world, they agree on the same neural network model saved in the blockchain, and people agree on the same training algorithm saved in the blockchain. Okay, in that case, so I can just load those global model into my local computer and run some training algorithm and update the knowledge, update the trained or a better version of the neural network onto the blockchain, so that people can continue improving that. Eventually, then we have this trained model can help us to do some the medical examinations or determine if a tumor is benign or malignant. Okay, so this is the basic idea. So let's just go to the background. I think that I have already covered most of the background, and also some other presenters in these days also mentioned the privacy issues in that. So the traditional machine learning environments centralize the storage of the data. They have the centralized storage for the data. They require the user to upload their images or private data to the centralized server. And you know, the centralized server somehow has the single point of failure problem. Okay, if some hacker just hack this server, all of the user data will be stolen. So sometimes you will heard some social network is hacked, and then some hacker just stolen, for example, 20 million user data there, and then this is because of the centralized server. There's a privacy problem at multiple fronts. Data owners has to put their trust in the storage provider and then their ability to prevent data leakage. User lose control over their data. Okay, that's very fatal. So okay, you trust some guy like the news. Then we heard some yesterday from Facebook. So Facebook, well, sometimes okay, Facebook just was charged that the Facebook sold out some user data. Okay, and then this is something. Okay, the data should be owned by you, but when you give the data to Facebook and you trust the data book, you trust the Facebook. But you do not know if the Facebook has ever used your data for some other purpose. It's very important for also the medical data, the medical record. Okay, so right now, you know, people right now can do the ultrasound exam in their home. You can just buy the very portable the ultrasound head. Okay, and plug that the ultrasound head to the tablets, and you can turn it on, and then there are just the images show up on your iPad. So people can have those medical data in their home, and also people can just test their blood pressure. The blood pressure, blood sugar in their home as well. Okay, so and also more and more the wearable devices can monitor your health status. So so we can use the machine learning then to help the people to have the better health status. Okay, you can have the low by just uploading your health record, and some machine learning algorithm running on the server can help you to choose some diet, and then you can and then do some proper exercise. Okay, give you some very professional suggestions. Okay, to keep you have a good figure, but all of the data could be malicious used. So decentralized machine learning would be a very adorable concept. For example, as I said, you can have some training data just in your local machine, or even not in your local machine, just in your local domain. For example, yeah, you have some data saved in your saved in your cell phone, but you at least have a computer in your home. Okay, then you can just send the data to the computer, the desktop in your home, and then run some machine learning algorithm in your desktop and commit the neural network change or neural network weights update to the blockchain. So that's the decentralized machine learning. And once successful adopted, decentralized machine learning aims at reducing the misuse of personal data by large corporations. And most importantly, you should know that why the Facebook can earn so much money, because the Facebook has a lot of contents, but those contents should be owned by you. But you never get a penny from Facebook. Okay, Facebook just provides you the platform and enable you and to share some data to your friends. Okay, but the people in Facebook, you know, they have a lot of advertisements. Okay, just plug those advertisements on the Facebook, but you should get some share. Okay, ideally. So if you have, for example, if you have this data, okay, encrypted, okay, and you train this neural network, okay, or you can have this data encrypted, and then eventually you can, for example, people realize that your data is very crucial and to improve the learning result of the neural network, then you can somehow make the data to be very valuable. And then other people may reach you, okay, and then you can, for example, make your data create some revenue for you. So currently, the organizations like Google are working in the field of the federated learning, but the federated learning is different from the decentralized machine learning. Federated machine learning is just, for example, the Google has a server in different corners of the world because Google do not want to pay the internet fee. You know that if every data is flowed into the center in the Silicon Valley, then that Google need to pay a lot of the internet fees and for that. So Google has a lot of server in different corners of the world, and then they would like to have the federated learning to have this something can happen in parallel. Okay, and then so this is just some good thing that the Google has already taken to try to protect the privacy. Okay, so here is our solution. The two lies at the intersection between the blockchain, decentralized smart contract, and deep learning. And then it intends to store the weights machine learning neural network model in the decentralized smart contracts. So later on you will see that we did create a smart contract and save those weights of the neural network. So people can load that, people can update that. This design can then be downloaded by the peers in the network to initiate and train their local model. So we still have the data, but we have the data trained only used for training in the local model. And then you can compare the improvement of the local model and versus the global model. Okay? And if you do have a good improvement on this global model, you can commit your local model to the global model, and the other people can download yours, the training results, okay, and then to their computers and use their data and to continuously improving the training results. The peers send the update weights to the blockchain, where the weights suitable according to choose matrices are stored. By using the system, the peer do not need to upload their data to any central server. Rather, the network is brought to them. So this is the one. Okay, so people, this is just the very basic picture for that. The data is never leave the local domain. Okay, and then after running the local training, the compare accuracy metrics and then make update if the accuracy is greater than the previous accuracy. So we still have some testing data. Okay, so for some testing data, it still should be public, so that I can every people that want to commit their local training results, want to contribute this community, then some authority can just release the training data. Okay, and then they can use their local data and to try to train this, to try to make this neural network works better. And then they can how they can determine that their data is a kind of contribution for this. So they need to run this training result with some sample data and to make sure they did improve the accuracy. And update the smart contract variables. Okay, if it is. And then the next device can just read the data from the read the updated weights from the blockchain, and then run their local training, and then this kind of loop. Okay, and we can also associate some contribution with some users' public key, and then we can bring some token model here. Okay, eventually then you can also say, okay, if I did improve a lot, then that I do not want to share my data just for free, because my data it is very useful and it can improve the learning accuracy very fast. Then sometime I will say that my data is very critical, it's very useful, so that if some research institute or university would like to see the data, then that my data will worth a lot. Okay. So some implementation issues here. So let me just quickly go through this, and then so we can see some demo quickly. We were able to implement the proof of concepts. So later on you will see the video. Our implementation works with any two-layer neural network, because we cannot just save every weights in the neural network. As Bruce said, for some the picture the categorization stuff, we already have 4,000 by 4,000 this kind of neural network, or even longer. Okay. 4,000 by, for example, 2,000 by 1,000, like the deep learning. So there are a lot of those weights. We cannot save all of them there. So in this proof of concept, we just save part of this neural network onto the blockchain, so that we just select the very last two layers. in the deep learning, okay, and save that weights in the blockchain. The data needs to be processed as is the requirement by every machine learning. So we just later on you will see the sample data, and the sample data is also public accessible. The user can choose the number of input, hidden and output neurons. For example, we have the two layers. Basically, we have the 3 layers of nodes. Okay, we have 2 layers. So we have the input, we have a bunch of input, we have the 1 hidden, and we have 1 output. For the output, right now we just choose 1 neuron. It's just a true or false. For example, when we train the data to test the tumor, then we want to determine if the tumor is benign or if the tumor is malignant. Okay. The code for machine learning model training loss function and Web3 code to access the blockchain is just a very basic operation to read and update the data on the blockchain. Machine learning training done by our implementation works in a way like the sequential model. So, for example, if you have if we have 1,000 pieces of data, we do not want to just simulate that 1,000 pieces of data is just in one local machine. We actually can simulate with 1,000 computers, and every computer just has 1 piece of data. And so this just like that, you can have this all the trainings with this 1,000 piece of data in a sequential manner. So first peer train this with this data, and then commit the change. And second peer download the updated weights from the blockchain and train its local data and commit the change. And the third one start to train, and first one start to train, is so on and so forth. So it's the sequential manner. But sometimes in the real case, one person may not have just 1 piece of data. Okay, one person may have multiple data sites, and so it can somehow improve the training training efficiency, because every time when you have the transaction in the blockchain, it takes some time. Okay, and also it needs to reach the consensus and to have this transaction confirmed, so the next person can start the training. It takes some time. But we can somehow, for example, if you trust your neighbors, if you trust some colleagues, then you can. It's just a dummy concept. For example, you just trust some people in the cluster, then you can aggregate this data into the cluster head and let the cluster head to train this data, so that you not need to commit the change for by peer each. So you can just commit the change of the neural network, the weights of neural network, cluster by cluster. So it's just something that to be happen in the future. So we will compare what's the learning efficiency or learning speed and learning result, comparing with the different cluster size. One of the peer initiates the training and upload the weights, I said, and then reset the peer follow one by one, download the weights, up the weights for their local training. And then if the local accuracy is greater than the global accuracy, then weights are updated to the blockchain. And in the proof of concept environment, we use all of those tools. I think that if you are familiar with the blockchain, they should not be strange for you. The ganache is just a kind of a simulation of the local blockchain. You just have a local blockchain in your computer, and so it actually has the same protocol like the Ethereum. And Matichuk just in charge of the wallets, so that people, the different contributor for this decentralized machine learning, they can have different public key, and we can know the improvement of the different data owned by different people. And the Ethereum and the PyTorch is just, for example, then if I run this machine learning in my computer, we right now that in this proof of concept, we are not implementing every machine learning algorithm in the Solidity, because it's quite difficult. And also we know if you are programming in the Solidity, you know that we have limited number of variables in each function. And also, if we want to update the weights of the network by using the backpropagation, also it takes a lot of time to call the derivatives using the smart contract. So we still use the existing package like the PyTorch running in the local computer, and you have your data in your local computer. We just save the weights of your neural network in the blockchain. And this Web3 Pi is just a kind of open library and to enable the people to access the data in the blockchain. As a contract, I said we have the weights. This proof concept can support any training with one hidden layer. Okay, any neural network with one hidden layer with one neural output and with any number of the input layer, and it can be adopted by this smart contract. Let me skip some of those. Yeah, so with the Web3 Pi, then you can, for example, set the accuracy in the smart contract, and then you can download the weights, and you can wait the transaction done. It just happens in every peer. I want to contribute this global model. You download something, and you train this local, and then you upload those, you update the weights to the smart contract. So we have the 3 experiments here, just for the proof concept purpose. The first one is very easy, just train a neural network to give the XOR output. Okay, so you know that the XOR. Okay, so we want to give the different input, different output, and eventually we can train the neural network for the XOR. The next one is the real case. We will detect the malignant cancer or just a benign cancer. And then in the third one, we'll train the full connected layers of the transfer learning model. This one is still being worked. As it says, we need to have the better coding to save the neural network weights in the smart contracts because it is it's quite large. It's quite large. All 3 problems uses a 2-layer model. Okay, we have 1 input, 1 output, and 1 middle hidden layer there. The data set for each problem needs to be processed in a different way, and we have done that already in this research. However, the underlying neural network and data set generation after processing can also be generated for these 2. The first one is just the XOR. Okay, so XOR, we have 2 input and 1 output. Okay, so you have this 1, 1, 0, and 1, and 0, 1, and 1, and 0, 0, and 1, 1, 1. They just give you the ones. Okay, so if this one, if they are different, it's 0. If they are the same, they go 1. Then this is very simple problem with the very small data set. And for this experiment, we assume that the same data set exists with all peers. Then we can train this neural network. Eventually, the simulation result can just get the correct result, and so people can do that. But in this one, we did not give that, since we are using the sigmoid activation. Okay, in the neural network, just use the sigmoid activation. The output is a probability value between 0 and 1. So there is, you know, the discriminant, and to determine what the result should be. It should be either 0 or 1. The conclusion for this one is we were able to save, retrieve, and update this 2x5 and 5x1 weights. You can see this is 2x5 and 5x1 weights, and for each of the peers. And then performance should increase with a greater number of devices in the system. However, since the data set is small, the risk we risk the overfitting. The next one is the real case, determine the malignant breast cancer. This is a more complex classification problem, and then we have just 683 records. The data record that can be accessed here is from the Wisconsin data set. The data set looks like this. The first column is actually not used. This is just the patient ID. It's not useful in this study. And then for those columns, okay, for those columns, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. The very last column is the result. So 2 means benign, and then 4 means positive. Okay, means that this cancer is malignant. And then for these 9 columns, we have the column thickness, uniformity of cell size, uniformity of the cell shape, and then marginal adhesion. Okay, you can see that different meaning of those columns, the size and the The last column is the target value. 2 refer to the benign cancer and 4 refer to the malignant. We pre-process this to change the 2 to 0, 4 to 1. Okay, just to make this 0 and 1, because neural network output, you have this output neural give you the value between 0 and 1, and you can just test you can just determine the result according to the threshold. The model is trained for about 100 epochs, and then each peer is a sequential manner. We can choose the learning rates between 0.01 and batch size 10. So let's see a video here.
Hello, everyone. So this is a small demo of one of the experiments that we did with our tool. This is the app file, and this is basically run by the initiator. For example, it could be a hospital that has all the patients, and it calls all the play functions of the patients. So one thing to note here is the initiator does not have any details about the about the patients, and that's what one of the main point of our tool was. So it just runs the program or the module, and we can see that the training has begun. You can also see that this is the first user and in our blockchain, and since this was the very first time the model was training, we didn't have anything to download from the blockchain. We just trained our model and we uploaded the weights. After the training and uploading has been done by the first user, the second user comes into action. He downloads the weights from the blockchain, and you can see that over here that initially the model had generated these weights, but we downloaded the uploaded weights from the blockchain and we changed them, and then we trained our model, and these are the new weights generated after training. We calculated the accuracy, and since the accuracy was greater than or equal to the global accuracy, so we updated the weights in the blockchain. Now we repeat these steps with peer 3. One of the main things to note over here is that the blockchain contains these weights right now. These are the weights that were uploaded by peer 2, and the weights that are downloaded by peer 3 should be the same as the ones that were uploaded by peer 2. And you can clearly see that this is the case over here. Here. You can see that these weights are exactly the same as these weights. And again, we go through all the same steps. And since the local accuracy is again greater than or equal to the global accuracy, it updates the weights in the blockchain. And then we repeat the same steps for peer 4, in case if the global accuracy is not less than the local accuracy, then the weights are not uploaded to the blockchain, and the peer just does the local training and updates the weights that were downloaded, and that's it. And then the system moves to the next peer. You can also see that the changes were made in the blockchain as well. We can see here that the balance has been reduced as per the.
So I think I just stop and at here for the video playing. So basically, this is using the connection as a local blockchain, but this is just a pro concept. We are not implementing this as this thing in the the mainnet. The transaction fee is very expensive, but at least we would like to launch this one in the testnet so that you can have the Ether faucet and play this online. So the experiment 3 is not yet fully done yet. So transfer learning. So we have the convolutional learning model here, and we want to just take out the very last 2 layer here. Okay, we just want to take the very last 2 layer here. So this is something. The convolutional learning is the convolutional layer here is actually just a module in the PyTorch. So even in the real learning case, the weights in the convolutional layers, they do not update either. So that we can just take out the very last layers, and we can have this 2 layer in weights in the smart contracts so that people can use this model, use this tool for some image training. But I said, in this two layer, it's like the 4096 by some value there. It's very huge. Then we can just try to do some coding on this. So what we are coding here is we would like to first have those numbers, and we change those numbers, cast those into the, those weights are actually just a floating point, but we cannot save the floating point in the smart contract. But we can code them by using the IEEE floating point standard. And later on, we will, when we load those weights in the PyTorch, in the Python by using the Web3 then we will change those weights back to the floating point. And we need to do some also coding to try to reduce the gas fee and or reduce the gas consumption, okay, for that. Yeah, so I see some question there, and we'll take care of that later after presentation. So the input node is 4096, the middle layer is 512, and output is 2. Some future work on this research is that we want to extend to the transfer learning. Okay, so here is the kind of the transfer learning. We will continue working on this. Add dynamics in the weight store in the blockchain. This proof of concept works for any two layers thing. With one input, one output, and one hidden. In the future, we would like to make this more dynamic in terms of the number of layers as well. We can also try to recode the single virtual machine, and to make sure that one also improve the block size in terms of the gas limit, and to try to have more data can be saved in one transaction. And make the two more generalized for machine learning method. Okay, for now, the two gives us the flexibility of choosing the number of input, hidden layer, and output. We would like to make it more generalized by using a standard customer neural network. For example, you can just give a model, and this model can directly convert it to be some smart contracts or the storage, the structure in the smart contract, and then also directly apply the data encoding, decoding to save those neural weights in the smart contract. Comparing performance of sequential and parallel model. So another concern about this kind of work is that if we just use the iris, if we just train the neural network in the sequential, it takes quite a long time. Then we can somehow have this aggregated training and just use the mathematical average for those weights. But you cannot just use the mathematical average just by one very small data set. Because if you just have very small set in your computer, some other people has a very small set in their computer, doing the mathematical average does not reflect the result of the backpropagation. So what we would like to have is that we have the considerable size of the data trained in the sequential. For example, in the cluster, we have 1,000 people or 100 people, and all of the 100 people in this cluster will train their local data in a sequential manner. Then we have some somehow a good or not very good, but it's a very rough training result. And then we can try to think about use the mathematical average for those results between clusters. But in that case, we can just use wait 100 transaction time, and we can finish all the training in the entire network. But what's the performance loss? Definitely there is a performance loss comparing with the training all of the data in a sequential manner. But what's the percentage loss that we can tolerate? Okay, so it's just kind of a trade-off design here. So we want to have something happen in parallel. We want to have something happen in sequential. So the sequential training takes some longer time, but the parallel can just happen this use this training aggregated training result very fast. But we want to have some analysis on these results and performance. And find the optimal hyperparameters for these two. It's just some very general idea for the machine learning research. So how to find the optimal epochs and how to find the best learning speed, like that. The potential applications for this tool, including the hospitals and private industries, speech and text processing and local devices, image processing on the local phones, such as that. The more important thing is that it can give the rights of the data back to the user. You still have the everything controlled by you. You can train the data, and when the people, and you can also commit a hash value of the data. If some malicious people want to just contribute some wrong data, first that firstly it's probably just to give you some the detriment for the global model. Probably your training result will not be accepted. But if some malicious people want to just treat the play against the system, another way we can deal with this is that we can save some hash value, okay, inside this transaction. Okay, for example, you have the data. You not want to review the data, but you can say, okay, whenever you want to commit the change of neural network rates, you can also commit a hash value of your training data. So that's when some people, okay, for example, some research institute want to buy your data, then you just need to show that, okay, then this data can create exactly the same hash value as you have committed in that very particular transaction when you're saving the ways to the smart contracts. This can just cannot prove that you are the owner of the data and you are not using some garbage data to play with the system. This is the very last slide. Hopefully I'm on time. The conclusion is that we have created a proof of concept for decentralized machine learning and to allow the people to collaborate in the network without the need of sharing their raw data, just contributing their the learning results. The solution should help give more power to the data owner and limit the issue of the pertaining to the data privacy. And for now, the two, just work in the 2 layers, but we will continue on this one and to support moderators and to also support more complicated neural networks. So thank you. That is the presentation.
Hey, thanks for Dr. Zehua Wang's presentation. And I have seen some comments or like questions in the chat. So probably you can take a look and answer these questions. Yeah.
Yeah, so it's very important to sell data in the manner. Yes, I know it's very expensive. It costs about 0.003 to call this contract without adding any data. So that's the yes, that is. So that I will echo the some people said about the consortium. Tim said about the using the private preserved learning. Sometimes we want to build the consortium blockchain. Yes, it is. So for example, the clinics, the hospitals, the medical research institutes, or some the pharmaceuticals, they can just make up a container blockchain and then can just do not need to pay the real user for this training. It's also well, I fully believe that in the blockchain's future, besides this the finite, that the cryptocurrency right now is the most popular thing in the blockchain, and then some project like the Polkadot want to how this multiple blockchains can bring together. But if we are not talking about the finance, because finance you need to do the exchange, and we must have everything in the main chain. But for the research purpose, for the learning purpose, it's actually just we have particular domain for different field. Okay, for the supply chain, it has a domain. So even inside the supply chain, it also have different domains. For example, the supply chain for the vaccine. For the COVID-19 vaccines, and it could be a particular domain, okay, in the supply chain domain. And for different domains, they can have different consortium blockchains, so that people can just contributing the data inside this consortium blockchain. And it can somehow reduce the gas consumption issue and the cost issue. Yeah. Okay, so the very interesting question. So yes, I'm reading this question from Stephen. Thank you for the question. Since the main goal here is to store the shared data, I feel maybe FFS is the better alternative to consider. Yes, so we could please use. Yeah. So the IPFS, it is. So we still, IPFS is that we can save the data in the IPFS, but the data in the IPFS must be encrypted. So for the saving this, yeah, the thing is we need to have a system and to make the people and know that where to find these weights, and then we want to have these weights updated globally. For example, if you have the IPFS, if you want to, okay, so how to maintain those weights in the IPFS? If you have this problem in your head, then we'll say, okay, whenever I change the weights, I can have two choices. One is I send a new address, so the people read this new weights from this address, okay? And then it also takes some time to propagate this one and to let the different people in different corner of the world to get the newest weights. But comparing with the Ethereum has the address. Okay, it's a smart contract address. So then you can know, okay, this address, whenever I read this data in this smart contract, those weights is the newest weights, is the updated weights. And another option is that, okay, and I will have the very particular address for the IPFS in the IPFS for this newest weights, but it still takes some time for the different IPF nodes and to synchronize the updated weights. Blockchain can help us to do this, just intrinsically, right? So because when you have this block mind and when you read this blockchain smart contract status, because in the Ethereum, the status is saved, okay, not by transaction, because every address has a status, has the this micro record in the IPFS. And then your the specialist, when you visit that clinic, the physician or specialist can just use their private key and to decrypt the information saved in the IPFS. And they can just only that particular the physician or specialist can check your medical record. So we are considering that IPFS can be used for the file storage, but for the neural network ways, we prefer to use the blockchain system. I'm not sure if I answered your question. Thank you.
All right. So actually, I have a question related to this combined machine learning with blockchain. So basically, we know that in this proposal, the on-chain logic is basically about the weights, the store, the retrieval, but the training process is basically off-chain, right? So it's always a difficulty or challenge that because to verify a deterministic program, the validator can do because the outcome is deterministic. But machine learning, like the training process is like it's non-deterministic, right? There's randomness there. So is there any kind of like insights or like future directions that we probably can do some lightweight, maybe we don't need to kind of like replay the training process, but is there any kind of lightweight validation process that we can maybe put not the training on chain, but also just the validation process on chain? Yeah. So
yeah, that's it. Yeah, thank you for the question. This is very good question. Yes, we know that. Yeah, so there is somehow a randomness. Okay, because the machine learning sometimes you want to jump out from the local minimum. You want to jump out and to test somewhere else in the searching space. So it is. So sometimes even you give the same model, you use the same neural network, the same way. You the same result, but sometimes the training result will be a little bit different. but the difference is still limited. So we can somehow determine the maximum range, or we can determine the range with that probabilities, or the CDF of this difference. For example, we can just have those weights, and you can just align those weights together, and you can just call it the distance. It's just like the 2 points in the hyperspace. And what's the Euclidean distance between these 2 points? Yeah, so some randomness, it can just you can think about this randomness can bring different points in this hyperspace, but the distance between this the previous point and the updated points, we will say there is a threshold. We can statistically or probabilistically and to determine what's the CDF of this the weight change or the variation of the weights. So in that case, we can somehow introduce some mechanism. For example, I have this data committed with some hash value. Okay, I have data, I committed my weights. I say, okay, this is my final result. And then I have this hash value. And later on, when the people, for example, when some algorithm want to verify this, so people can, for example, have this data encrypted and save the data into the IPFS. And then some algorithm can just bring those data, and then if the data can be remotely decrypted by using this person's authorization, or the user just decrypt this the data and then have some online verification. And then if this result is within the Euclidean ball in the hyperspace, okay, with some probability, then we can still implement some verification by that sense.
All right, so I understood that we can have some like bounding box for these like results, so that make sure this is correct. Oh, all right, so I think it's about the end of this section. So I have to like hand it over to Irene. Yeah. So thanks for the brilliant speech from Dr. Zehua Wang. Yeah.
Sorry, I think Irene, you muted.
The mic is mute.
Yeah, so I have to repeat what I said. So thank you, Dr. Wang. And I introduce the next speaker, Xinyao Sun, and we normally call him Alvin. So Alvin is in his last year of Ph.D. study, but his research did not start from his Ph.D. program. He worked with Xinyao and Xinyao back in their undergrad study, which established his interest in entrepreneurship. But one research I have to mention is the aerospace project. When a satellite surrounds the world repeatedly and captures data from a particular location, for example, California. So based on the spatial temporal data, scientists are able to predict the trend of ground displacements, which may suggest forthcoming landslides or volcano eruption. So waiting for the satellite to collect multiple rounds of data is time consuming. Alvin and his teammates have reduced the number of scans used, so we call insert data, from 30 to 1. So it is quite a big improvement. So over the last 8 years from his senior undergrad period, he has worked on many application challenges. Today, he will tell you some of them. Let me invite Alvin.
Okay, yeah, thanks, Professor, and also thanks the Professor Zehua for gave a quite interesting talk. And actually, my topic is probably a slightly overlap and cover the same thing, because I'm going to talk about the data-enabled multimedia research with blockchain. And yeah, but thanks for like all the previous speakers that they already gave like the comprehensive coverage on many introductions, examples, and potentials for like both data science and the blockchain technology. So my talk will mainly focus on the case studies to give some industrial and research examples from our lab as well as from the literature. Yeah. Okay. So we know that blockchain is a fundamental technology that is revolutionizing how transactions are conceived, executed, managed, and monetized. So while the commercial benefits of the blockchain infrastructure are imminent, the underlying technical problems need significant attention from researchers. So of specific interest to researchers and application developers in data science, it's tremendous opportunity to make the connection to these emerging infrastructure capabilities and realize how their skills can be leveraged to make an impact by data science and blockchain technologies. So this marriage can happen in two ways. So firstly, the data-enabled multimedia research can be exploited to address the critical gaps in blockchain platforms, such as the scaling, the modeling, and privacy analysis. And secondly, as the world moves towards increasing decentralization, a blockchain-based infrastructure would be essential to create the necessary trust between the diverse stakeholders in the whole data-enabled multimedia application ecosystem. So many complex practical challenges, such as the stakeholder identity management, the compliance of the regulations, and the like the integrity of the data, the protecting privacy of the sensitive information can be effectively addressed using the blockchain technology. So to this end, in this session, I will first give a brief definition of the multimedia. Then I will quickly go through the selected recent data-enabled multimedia research in our Multimedia Research Center, and followed by the integration with both cases I just mentioned before, like how blockchain can potentially benefit the data-enabled multimedia research, as well as how data-enabled multimedia research can improve the existing blockchain system. So what is the multimedia? It actually can be simply derived from the word multi and media. So the multi means many, multiple, more than one, and media denotes the distribution toward and the information presentation. So in generic sense, multimedia is simply a combination of different media elements, including text, graphics, animation, sound, video. So you may realize that the multimedia research is quite a broad research topic, especially everything stored digitally nowadays, and different types of data just in different representation of zeros and ones from the computer point of view. And the size of number of such available data has grown rapidly as the data is collected by devices such as the mobile devices, chip and numerous information sensoring IoT devices, the area remote sensing radar sensors, software logs, cameras, microphones, or even the wireless sensor networks. So the world's technological potential capacity to store information has roughly doubled every 40 months since the 1980s. And of the 2012, every day, 2.5 exabytes of data has been generated. And there is one assumption by 2025, the IDC predicts that there will be around 175 gigabytes of data will be generated. So to this end, the multimedia research is data enabled by its very nature nowadays. And Professor Anu Basu have already given some examples of our ongoing work relating to the computer vision and the computer graphics yesterday. Actually, in Multimedia Research Center, we have different research groups supervised by both Professor Basu and Professor Irene. We keep very close collaboration and partnership with many industry companies to focus on many different types of data for resolving different real problems. So it includes not only the healthcare research to better protect the elderly and seniors, the aerospace remote sensing project for wide area monitoring, as well as the video surveillance technology on image processing and computer vision, and 3D modeling and animation for robotics, human-computer interaction on the computer graphics. So basically, in our Multimedia Research Center, we involve many fundamental research fields. The image processing, computer vision, computer graphics, and artificial intelligence. But for solving many different fundamental research tasks, like the filtering, quality assessment, recognition, classification, decomposition, and signal simulation. So they are all let us serve the real world industry partners to help them to solve the real world industry problems. So here I will just pick some ongoing projects from our research groups. So here is one healthcare research work done by the master and PhD students, Summer and Sarah. The Parkinson's disease is one of the major nervous system disorders that affect people mostly over 60. The PD can cause the cognitive impairments. So in this work, they adopt the diffusion tensor imaging, the DTI biomarkers data that have been established as one of the leading techniques to help diagnose the disease. But however, identifying patterns and deducing even the preliminary results require a neuralist to analyze the scan. So in this work, they propose a learning-based model that can analyze the DDI data and predict if the person has the PD. So they are able to obtain a classification accuracy around 80% on new data. And as an extension, another PhD student, Taji, further explores the various approach to identify the PD use the MRT1 images of the brain. So he experiments with an ensemble architecture and adaptive region of interest section on gray matter and white matter regions from the MR images instead of using the whole MR images to achieve an average accuracy around 98%. So that is actually very relevant to what Professor Basu mentioned yesterday about the attention-based analysis. So he also performs Taji also performs occlusion analysis and determines which brain area are most relevant to the architecture decision-making process. So which is actually quite essential nowadays to explain reasoning of a learning-based model. And here is another example for the medical image processing done by the multimedia master students. So as anonymous medical image scanning devices, so ultrasound has greatly increased the efficiency and accuracy of the medical diagnosis. So in recent years, the portable ultrasound is being more widely used for its convenience and lower cost. So patients and physicians can receive the scanned images on their mobile phones at any time via the wireless network with a low latency. But however, it is difficult for portable ultrasound devices to capture images with the same quality as the standard hospital ultrasound image accessing system. But usually, the images captured by those portable ultrasound equipment have considerable noise, and this noise affects the diagnosis of the physicians. So students propose a novel denoising neural network model called the feature-guarded denoising convolutional neural network to remove the noise while retaining the important features information. So in order to achieve high-quality denoising results, they employ the hierarchical denoising framework driven by the feature masking layer for medical images, which is another attention-based study. So furthermore, they propose a feature extraction algorithm based on the explainable artificial intelligence for medical images, and experiments show that the feature extraction methods outperforms all other previous results, and combined with the newly residual learning neural network architecture, they can perfectly remove the noise as well as retain the key features from the portable ultrasound devices scanned data. And the same filtering requirement is also needed for the remote sensing area. So over the past decade, using the interferometric synthetic aperture data, it's just introduced by Professor Irene. This sort of remote sensing technique it has been widely used for ground displacement detection and has become very successful for millimeter precision. But however, during the excitation stage, the microwave signals reflected from the ground and received by the satellite are contaminated. So for example, due to the undesirable material reflectance and the atmospheric factors, and there is no clean ground truth to discriminate this noise. And at the same time, accurate signal filtering and quality assessment are very crucial for subsequent analysis. So current methods require X-ray separation, and extensive runtime to evaluate the quality of the intermediate output, which limits the usability and scalability in practical applications, such as the wide area ground displacement monitoring and prediction. So in this work, our team proposed a deep insight to intelligently solve both signal filtering and quality assessment problems. And we introduced a teacher-student framework to handle the issue of missing clean inside ground truth data during the training stage. And we adopt a differentiable model to mimic the behavior of the traditional algorithm and human expert knowledge, which are undifferentiable, and at the same time achieve better performance with less number of required inputs. The commercialized version of the Deep Insight has been successfully deployed in Zehua company in Vancouver to serve their clients all over the world and handle hundreds of terabytes data every week. And to further explore in this direction, to overcome the previous work's the potential limitation that we still have the requirement of the teacher. So we decided to explore the signal property from its own. So we thus proposed the Cheng Insight, which is a self-supervised model to learn and predict the pixel level signal distribution. So during the training stage, there is no need for any ground truth or reference label data. The model can, based on the spatial characteristics of the signal as well as the global information, to estimate the distribution, the latent signal distribution for each pixel location. And after that, for any given noisy image, we can use the model to predict the pixel level distribution and just use the mean as the filtered noisy free signal and use the standard deviation to derive the quality, because the standard deviation is actually the uncertainty of the signal quality. And another work has been done by the PhD student Cheng in MRC. The Professor Basu has shown this work yesterday. And in this work, he focused on automatically learning the distribution in temporal video data using a novel background subtraction model called the dynamic deep pixel distribution learning. So unlike the remote sensing work we have done before, this work is trying to to learn the distribution and give the prediction. And our previous work is actually based on the spatial features to predict the distribution. And in this work, Xinyao proposed a model to learn the temporal pixel distribution to give the prediction and to classify whether the pixel is the background or the foreground. The evaluations using the standard benchmark demonstrate the superior results of the proposed approach compared with the state-of-the-art, including the traditional methods as well as the deep learning methods. And here is another sample work done by the PhD student Shu Pei. So we know that natural images may suffer from the limited image dynamic range that affect the visual quality. Shu Pei proposed an algorithm utilizing only traditional image processing techniques, a contrast-based fusion algorithm. So first, the original image is segmented into the multiple regions. Then several enhanced images are generated and evaluated for their quality. So finally, the best enhanced images for each region is selected and then fused together. So he achieved a better performance over the state-of-the-art with purely image processing and mathematical algorithms. And the last example work is done by the postdoc Nassim and the PhD student Gabriel. So in this work, they collaborate with the local robotic company to focus on the task of recognizing an object and estimating its six-dimensional pose in a sense. So the accessibility and low cost of the consumer RGB cameras to make object recognition and pose estimation feasible even for the small industry business. So they are trying to improve the company's industrial assembly line. Well, the robotic arm should pick a small textureless and mostly homogeneous object and place it in a the desired location. So despite all the recent advancements of object recognition and pose estimation techniques in natural things, the problem remains challenging for industry parts. So in this work, they present a framework to simultaneously recognize the object's class and estimate the six-dimensional pose from the RGBD camera. The proposed model adopts a global approach, while an object and the region of the interest are first recognized from the RGB images, and the object pose is then estimated from the corresponding depth information. They train the various classifiers based on the extracted features to detect and recognize the objects, and then perform a template matching on the point cloud. So based on the surface features to estimate the pose of the object. And experimental results show the system is quite efficient, accurate, and robust to the illumination and background change. So because of the time limit, I only present some of our recent ongoing work from Multimedia Research Center. But overall, when I describe all those works we are working on, there are three main entities involved in the whole ecosystem. So they are data provider, algorithm provider, and service provider. So in fact that most of the time, three entities are not belong to the same party. So how they can trust each other, especially when deals with the private data, content privacy, and IP. So to ensure a secure and trusted data-enabled system, that would be a potential of how blockchain can be involved. So let's just review the blockchain a little bit. So it is a decentralized ledger. It is a way how to store the data. It brings the cryptography, proofs, consensus mechanism, and decentralization together. The development of blockchain technologies has experienced two main phases so far. The first is blockchain 1.0, symbolized by the digital currency. In blockchain 1.0, blockchain has been mainly used for the digital currency like the Bitcoin for P2P transaction. The Bitcoin is the most famous blockchain white paper. It introduced a new way of exchanging and storing data using the public ledger. And the second is the blockchain 2.0, symbolized by the smart contracts. So the appearance of blockchain has promoted the development of smart contracts. So it was the first introduced by the Ethereum, which is the second most famous blockchain white paper. So it improves on Bitcoin by adding the Ethereum virtual machine and smart contracts. So a smart contract essentially consists a number of computized contractual agreements consented by multiple parties. So it can execute code in a word-shelled Turing-complete machine. So to this end, how blockchain can potentially benefit the aforementioned data-enabled multimedia research or data-enabled research, data science in general. The first is for user-controlled data sharing. The data is considered the new goal in today's data-driven economy. So availability of massive amounts of data is one of the major driven force for the data-enabled multimedia research. But however, extraction of data for data analytics is a complicated affair. So unless you are a big player nowadays, mainly due to the current privacy concern that also Professor Zehua just mentioned, that you trust big companies, such as Google. When Google wants to show ads to you, the more data you send to Google, the more Google knows what you mostly like to click on with a certain degree of certainty. And the more accurate of such prediction, the more expensive they can sell the services to the company, the more money they get and the more data they can get. So blockchain integration can encourage data sharing from a single person. So with its inherent feature of accountability and transparency, the users can thus be aware of all the details of data, like who accessed his data or when it was accessed. So blockchain helps to give the control of the data to the users, providing them more confidence for sharing it. The potential impacts of this kind of data sharing will be tremendous. And here is a real-world example platform called the Ocean Protocol. So under the scope of the Ocean Protocol, they guarantee data owner retains the control of their data. So if you don't have the key, you don't control the data. So there involve no center authority during the whole data processing pipeline. It allows for block reward to incentivize the data provider. The blockchain integration can enable the sale of the data with the help of the smart contracts. So this lays the platforms for security and private data market without the middleman. And this marketplace level the ground for all players, lowering the barriers of the competition and fostering the innovation. So Ocean Market allows you to publish data, state on data, and buy data. And data is published as the interoperable data tokens. And they also introduced the computer to data, enables the private data to be bought and sold. So it is a decentralized exchange, but specifically tuned for data. And the computer to data resolved for the trade-off between the benefits of using private data and the risk of the exposing it. So it lets the data stay on premise, yet allows third parties to run specific computer jobs on it to get useful computer results like the averaging or build any model upon that. So Ocean Protocol aims to provide the whole system more data, the provenance and earning opportunities. So as a data scientist, you can benefit from access more data, including the private data and crypto security provenance in data analysis and income opportunities for selling the data. And another thing, all the actions of publishing data, purchasing data, consuming data, they are all recorded on the blockchain to make a tamper-proof audit trail. And Ocean Protocol more focused on the data provider. And Singularity Net is another project mainly focused on the algorithm provider and service provider. So it is a decentralized AR marketplace created to democratize the use and development of the AR applications. So it performs in a very similar way as the Ocean Protocol, but their market is mainly for selling the model and services. So all transactions are recorded on the blockchain to make a secured and trusted decentralized market system. So although many data-driven algorithms have been successfully in building an autonomous system, users face a reluctance in adopting them. This is because many of the decisions made by these systems are not explainable to human users. So to ensure better adoptability, it is essential to build an immutable trail that tracks the data flow in the data-enabled processing system. And blockchain technology at the same time enables this by tracking the decision-making and data processing at every turn. This knowledge of clear trail will help human users understand the whole process better. And at last is the coordinating devices, like the cell phones, IoT devices, or swarm robotics, and making joint decisions hold bright possibilities for the data science in the future. And applications of these systems can range from the coordinating robots on the tactical missions to updating the software for devices such as the refrigerator at your home. So the integration of such platform with blockchain will improve security, protecting the systems from the potential hacks. And here is one example work has been done by the alumni from the Multimedia Research Center, Wang when he was working in SAS, which is the data science company. And he pointed out that the machine learning algorithm often use data from databases that are mutable. So therefore, the data and results of machine learning cannot be fully trusted. Although the learning process is often difficult to automate, so they propose building a trusted machine learning system by using blockchain technology, which can store the data in the permanent and immutable way. So in addition, smart contracts on blockchain are used to automate the machine learning process. So this work investigates how to enhance the data efficiency in such a framework to bring computer vision system to the edge. So it presents the three-step approach. First, a lightweight machine learning model is trained on the server layer. And second, the trained model is saved in a special binary data format for data efficiency. And finally, the streaming layer takes these binary data as input source, incoming new data in an online fashion. And real-time semantic segmentation for autonomous driving is used as an example to demonstrate how this approach works. Actually, this work is quite similar as the work has been just presented by the Professor Zehua. So you can actually imagine that how popular this sort of the integration between the machine learning and the blockchain happens nowadays. And to this end, the integration of the blockchain with the data-enabled research are mostly done by treating the blockchain as the verification layer or the authentication layer or authorization layer. It's just like the team just mentioned. The complicated or the computational expensive steps still done off-chain. So the previous works mostly apply the crypto economics incentive to governance the whole ecosystem, but it still lack of the practical, efficient consensus strategy for the computational model due to the limited on-chain computational power. But as the blockchain 3.0 is coming, which is specifically focusing on the scalability, there must be more potentials in this field in order to build a better decentralized data-enabled research, multimedia research, or data science. And however, until now, all previous work I just mentioned are mainly concentrated on exploiting blockchain for data-enabled multimedia research, as to overcome the emerging security and privacy vulnerability. But the blockchain system, at least for the current blockchain systems, also lead the following challenges. The first is the operational maintenance. So due to the decentralization of the blockchain system, it is difficult to identify the potential facts affecting the performance of the blockchain. And the second is the qualified assurance of the smart contracts. The smart contracts suffer from a number of software vulnerabilities such as the overcharging issue, randomness control, and decentralized autonomous organization attack. The last is the malicious behavior detection. So besides the legal businesses, the blockchain may be exploited for malicious activities, which are nevertheless difficult to be detected due to the anonymous property of the blockchain. And to this side, the blockchain is actually a source of new modality of data for data-enabled multimedia research. The appearance of the diverse blockchain system has generated the numerous volumes of blockchain data, which are public available to everyone. And the data analytics on the massive blockchain data can not only extract the huge business value, but also bring great opportunities to overcome the aforementioned challenges of the blockchain system. So the first, like the intelligent operational maintenance of the blockchain. The blockchain generates a huge amount of data in real-time manner. Analyzing blockchain data, we can detect the possible faults, forecast the values, and identify the performance bottlenecks, so far to tune and adjust the performance of the blockchain system. The descriptive analytics can be used to evaluate the performance. Meanwhile, the diagnostic analytics of the blockchain log data can help to monitor the real-time performance of the blockchain system and identify the possible faults. So in addition, the predictive analysis is also necessary to anticipate the performance bottleneck of the blockchain system. And the last is the prescriptive analytics can simulate and optimize the blockchain system so as to improve the reliability of the current blockchain system. So here is the sample work that points out the blockchain system with the characteristics of the decentralization, irreversibilities, and traceabilities have attracted a lot of attention recently. But however, current performance of blockchain is poor, which becomes a major constraint of its application. Additionally, different blockchain systems lack a standard performance monitoring approach, which can automatically adapt to the different systems and provide the detailed and real-time performance information. So right now, the most famous metric is the transaction per second, but it is actually not enough. So to solve this problem in this work, a detailed and real-time performance monitoring framework for blockchain system is introduced. So they define an overall performance matrix as well as a detailed performance matrix, and build a framework and build a performance monitoring framework with a log-based method for users to know the exact performance in different stages of the blockchain. So they present some interesting comparisons to use their matrix to compare the performance and evaluate the performance between the different blockchain systems based on their different design, as well as do the detailed performance analysis on the Ethereum blockchain on different stages. And the next is the intelligent quality assurance of the smart contracts. So like computer software, smart contracts may contain bugs or faulty programming codes, so which are vulnerable to crashes or malicious attacks. So it is crucial to detect and identify bugs in the smart contracts so as to achieve the ultimate goal of the the intelligent quality assurance of the smart contracts. So the work of the Oriental is to present the symbolic execution platform to detect and recognize the potential bugs in the smart contracts. So meanwhile, the smart contracts are also essentially program codes that are sensitive to execution cost. So for example, in Ethereum, the execution cost of the smart contract is charged by gas. So thus, it is necessary to identify the gas costly patterns and correct these vulnerable smart contracts. The Gasper is a tool developed to identify, to locate a set of gas costly patterns while analyzing the byte codes of the Ethereum smart contracts. And this also revolves a new direction for the data science, like use the machine learning or deep learning models that can be used to detect and recognize the vulnerable bugs in the smart contracts automatically. So moreover, the growing number of smart contracts also brings opportunities to automate the composition of the multiple contracts by like the data mining techniques. So in particular, we can find the identify contracts that fulfill users' requirements and compress them together to realize a more comprehensive applications automatically. And the last is the automated malicious behavior detection. So the decentralized blockchain system result in the difficulty in auditing malicious behaviors such as the money laundering, the phishing and scams that occurs in the blockchain platforms nowadays. Actually, the blockchain system has generated massive transaction data, which are essentially available to everyone. And the data-enabled multimedia analytics on massive blockchain data could potentially help to identify malicious users, recognize behavior patterns, analyze the market manipulation, and detect the scams. So here is an example. They point out that the blockchain data can actually exploit it by conducting the illegal activities. So the author proposed a method to detect the Ponzi scams in the Ethereum blockchain through extracting and analyzing the key characteristics of user accounts and operation codes in the Ethereum contracts. So they made a comparison between a normal lottery contract and a Ponzi scheme contract in terms of the Ether flow graph. So they can observe the several significant difference between the visualization of the Ether flows. So this actually prevents the key findings that after extracting the key features of the abstraction of the transaction data on the chain, so it is possible to apply the data mining and machine learning methods to classify the Ponzi scams from other normal activities in order to give the warning to other users in the blockchain community. So here is another example using the graph analysis to understand better the Ethereum network. So being the largest blockchain with the capacity of running the smart contracts, Ethereum has attracted wide attention in the past couple of years. But little is know like what happens and how about the characteristics of its user smart contracts and the relationships among them. So to fill in this gap in this work, authors conduct the first systematic study on Ethereum by leveraging the graph analysis to characterize three major activities on Ethereum, namely the money transfer, the smart contract creation, smart contract invocation. So they design a new approach to collect all transaction data, construct three graphs from the data to characterize the major activities, and discover the new observations and insights from these graphs. So moreover, they also propose a cross-graph analysis to address the two security issues in the Ethereum to detect the attack and anomaly actions. So basically, people said the data-enabled research or data science and blockchain are yin and yang. So they actually can compromise each other. The data-enabled research or the data science, we are trying to modeling and approximate the reality, but on the other side, the blockchain is designed to record the reality, and the data-enabled research and data science, we try to approximate the reality based on some probabilistic algorithm, And our data, our model, the metadata configuration, everything is changing, which is mutable. At the same time, the blockchain is actually designed to record everything deterministic and impermanent. So despite all the developments and achievements taking place in both the blockchain and data science space, so there is still a long road ahead of them. The advancements achieved by the technologies with respect to the algorithms, protocols, computing powers, and data management are still insufficient to cope up with the complexity of the human world. And data science and blockchain are among the key drivers of the innovations we witness today. So by introducing the radical shifts in our day-to-day life, they are all set to fundamentally reshape the way we live, interact, and work. So being the most disrupting technologies, they are expected to contribute trillions of dollars to the global economy in the future. And here I just list some potential research topics that also the White Matrix and Multimedia Research Center are collaborating and propose. So, however, on the road to the future, the convergence of the data science and blockchain offers unlimited possibilities that can be realized with more research and development, I believe. So, okay, that is the end of my presentation. Thanks, everyone.
Thank you, Alvin. So the audience, any question?
So yeah, I have a question. Basically, yeah. Can you hear me?
Yeah.
Yes.
All right. So I think currently just from a maybe broader view, right? So